Thank you. I think I'm ready. Can you guys hear me okay?
Yep.
Okay, perfect. So first of all, thank you for having me here. I'm very excited to present at this OWASP, and thank you for everybody to joining on YouTube channel to watch. As mentioned, if you have any questions, please type in your questions into the channel, and I will be taking a pause every few minutes to go through the questions that you may have for me. So today we're going to talk about software security programs, the basics about software security programs, some of the pitfalls and some of the common mistakes that we see in the industry, and some of the suggestions of what to do and how to actually measure the success of your program. Okay? So when we talk about software security program, what first comes to mind? To a lot of people, it's talking about things like penetration testing, static analysis, patching, fixing bugs, and a whole bunch of other things where you're in a cycle of finding bugs, mistakes in your applications through various testing means and then fixing them. But is that really a program? And what I would like to let you think about is that I don't think this is a program. This is not a program. This is what I call bug squashing. You developers produce some bugs, security professionals find some bugs, tell developers to fix them, they fix them, and then they produce them all over again, and that cycle never stops. You're constantly trying to reduce the security debt that you have within your organization and in your software. So how to stop it? Will it ever stop? And the other question, what is software security to begin with if it's not about finding bugs? Okay. So before we go through and think about what is software security, I want to talk about some of the more famous hacks that happened in the last few years, last 5 to 10 years, like with Capital One, Equifax, and Target. I'm assuming a lot of you know some technical details about what happened, how they got hacked, how the bad guys got in. But what I would like you to do is to challenge you is think about it from a slightly different perspective. Let's think about it. What do those hacks tell us about capabilities or lack of capabilities within those particular organizations? So if you think about Capital One, and again, this is based on public information that I have access to based on my own thought process. That particular hack telling me that there's a good chance they want to take a look at their capabilities about how they do their deployment hardening, right? How do they harden their assets within the cloud infrastructure? They may want to take a look at the capability of the overall security architecture. How do they go on day-to-day basis and review the architecture of various applications and systems that they have? Now, if you look about Equifax, now Equifax got hacked through open source software, and if they have some tools to run and find those bugs and actually look at them, they could have fixed it. But what does it tell you about the capabilities? Well, a couple of capabilities that they probably want to take a look at and try to strengthen within their overall program is open source governance. How do they govern what code they can have or allow within the organization? And how they actually manage the vulnerabilities through their life cycle once they actually find them. And similar, you can think about Target, and with regard to Target, some of the capabilities that they probably want to take a look at is how they manage their vendors and how they define their secure SDLC. So as you notice here, this was about capabilities. So this is going to be a preview of what we're going to talk about. That software security programs and building software security programs is about building capabilities within the organization. Okay. Now, before we go through, just to give you a quick introductions about who I am and what organization I work for. So I work for Synopsys. I've been with the company for about 6 years, and we're an application security solutions firm. And it started through, I personally came through acquisition of Cigital, and Cigital has been around for close to 30 years working in application security. So a lot of things that I'm going to present during this presentation is lessons learned from over the last 30 years from a lot of work that we've done with large organizations, measuring their software security programs and seeing what works, and also helping build these programs for a lot of large organizations. So that's where this content is coming from and the lessons learned. About myself, I said I'm a managing principal, so I've been with the company for about 6 years. I'm a former embedded developer going back to 1990s, where if you know anything about embedded development and want to talk to me about pointer arithmetics, jump tables, bit manipulation, bit shifting, let me know, and we can talk about ISRs and printfs, and probably I'm going to get too excited thinking back to how I started. I'm also one of the consultants at Synopsys who measures those programs. So in my personal experience, I probably looked at 20 large enterprises and I've measured their software security programs as well as giving them advice on how to improve them. From a personal note, I have 3 kids. They're all competitive swimmers. So before the current situation, I used to spend pretty much every weekend of my life for the last few years at various swimming pools, at various swimming competitions. Okay. So that's a little bit about myself. So let's talk about why would you even want to build a software security program? Why can't you just keep on finding bugs through pen testing, static analysis, whatever flavor of the day testing methodology you want to have, and just keep on fixing them? So on this slide, I present to you data that's actually been posted by one of the large healthcare organizations in the US about how they build the business case to actually build the proper program versus just to continue testing. So what you see on the left, and this is all real data. This is not our data. This is this organization data. And you can take a look at the link at the bottom of the slide and actually read about their program and how they made it happen. So what they've done, they actually looked at the real life data of how much money it cost them to find the bugs, right? And they look at real costs of where they find the bug in their life cycle. And I'm sure you've seen a lot of various versions of this particular diagram, that the further right you go in USDLC, the more money it costs. So they did this number crunching, and it went all the way from about $140 to $14,000 to fix the issues once the application is in maintenance. And they looked at the overall cost of fixing all of the vulnerabilities, and that was about, as you see in the chart on the right, about $30 million. Now, obviously, this is a large organization. This was Aetna, and they had a lot of bugs. What they've done, they actually started building a software security group. That's what SSG stands for at the bottom right corner of the right diagram. And then they measured the overall cost to the development organization that it takes them to fix all the issues that they're finding now. And they reduced the overall spend by about $20 million by shifting left, finding bugs earlier in the life cycle, and fixing them earlier. So an example of why organizations and development communities would want to build software security programs may not necessarily be about risk for them. It may be about cost savings that it takes them to fix the vulnerabilities to comply with whatever security requirements that particular organization has to comply with. Okay. I'm going to take a pause. Just wanted to check to see if there's any questions for me from the chat.
Folks in the chat, if you have any questions, just feel free to type them in, and I'll repeat them for Eli.
Okay. Okay, so going on the next slide. So let's talk about what a software security program looks like, a software security initiative. And the way I like to define it, it's the organization's end-to-end effort to organize and coordinate to improve the security of all of their software assets, okay? And the single most important thing that organizations can do to build software security program is actually to formalize the efforts to organize themselves. And what does it usually mean? It means that you want to have a single individual within the organization who is accountable for software security assets from end to end. And it's not as simple or as common as you would think. I can't name how many organizations I've seen where people who are in charge of application security and have title of director of application security have very limited accountability for end-to-end for ensuring security of their software. In some cases, these directors of application security are basically running testing programs with very little other responsibilities. Some organizations may run some standards as well, but they have no influence on how people actually design and architect their software. So really the number one step to success is to have a single person who's accountable for end-to-end on all of the various aspects that it takes to build secure software. Now, if you want to know what does it actually mean in real life, what are all the different components that go into building secure software, you can take a look at some of the common frameworks, open source frameworks that exist out there. There's SAM from OWASP that talks about, I think, 15 different areas that go into building software securely. We have our own open source framework, BSIMM. You can look at some of those frameworks and learn what are all the set of capabilities and responsibilities you need to have. Now, once you appoint somebody in charge who has full range of necessary responsibilities and accountabilities, you actually need to build a program that relies on people, governance process, as well as verification and defect discovery. So one, you want to empower people. And this is not just developers, not just people who write the code. This is QA, this is project managers, this is business analysts, architects, your DevSecOps engineers, your everybody who's involved within USDLC to learn about application security, to understand what it means and what it means to the organization. You need to define the processes and how you're actually going to do things. It's great that you found vulnerabilities. What do you actually do with them? How do you close them? And also, it's very important to define your KPIs and your KRIs. For people who don't know what it stands for, that's your key performance indicators and key risk indicators. This is how organizations measure their success and measure their risk on various initiatives, not just software security. So defining them in a right way that actually allows you to measure the right things is also critical. And we'll talk a little bit about that later in the presentation. And then the last component is going back to actually finding the bugs. You want to verify that you're doing the right thing. You want to find the issues that developers produce, and then you want to fix them. So fixing bugs is part of the program, but it's not the program, right? Okay. So moving on to the next slide. So the next few slides are going to talk about some of the common software security problems that we see, how organizations try to build the programs in the wrong way, and we're going to give you some advice. Okay. So first one, a lot of organizations think they have a software security program, but in fact they don't. Okay. They have all different capabilities distributed across different organizations, different managers, sometimes even different executives, and nobody's really connecting the dots or having a big picture of end-to-end software development and software maintenance. And there's a lot of silos. People are having their own silos. I'm responsible for penetration testing. The other team is responsible for security architecture. Third team is responsible for threat intelligence, and they never talk to each other, right? A very common example that I see is that you have these great smart guys who are sitting in a dark room, closed off from the rest of the organization, reading through thousands of threat intelligence feeds, learning about all the things that bad guys do. And then that information, that great information, never makes it to developers, so developers do not know how people exploit the mistakes that they make, right? And this is what I'm talking about, silos. So a lot of organizations don't connect the dots. And one of the things that the lead, the overall person accountable for the program, one of the greatest challenges is breaking the silos within the organization and getting people to talk to each other. Okay, that's one. And by the way, these ones are in no particular order. I have 10 of them that I'm going to go through. The next one, it's processes. If you think about the history of information security, it started in the 1990s where what we did, we built firewalls. It was very network-centric security approach. and information security build processes, build workflows, build processes for how development teams engage them in a way that makes sense for information security. Okay. And what did they try to do next? Once they start thinking about software security, they try to take their information security processes and give them to development teams. But the development teams, especially in the last 5 years to 10 years, with the new development approaches, with the DevSecOps, Agile, these processes no longer work, right? And the way information security expects development team to engage them no longer works, right? So one of the lessons here is that whoever is defining the processes on the information security side, they need to define the process not in a way that makes sense for information security and application security. They need to define those processes in a way that makes sense for the development organization and how the development happens within that particular organization. Okay. It's going to take another pause. Are there any questions on the chat? Okay. So next one. Next, a common thing that we see that organizations do, and it's very much related to the one I just talked about, is building the programs that are built extrinsic of development processes, right? Where security guys are trying to chase the development team to do the right thing, right? And in many cases, security team says, well, now everybody's agile, so our old processes no longer work. And if you think about the way things used to work, is that security teams would build gates, and security teams would be the gatekeepers before the project would go into production. And if a development team wanted to go into production, they would have to show up in front of a gate with the right key, let's say a green key that represented a clean pen testing report, show it to information security. Information security would review the reports and give it a green light. Now, this is a very human driven process, right? Humans are presented with data, humans interpret the data, and then humans make a decision of whether you can pass the gate or cannot pass the gate. Now, that doesn't work in today's environment, where all development teams drive towards automation. Now, what security teams done next is that, well, you want to automate? Great. We're going to add static analysis engine to your build process, which means you're going to run your static analysis every night, for example. Well, that's great, but that's not really automation. At the end of the day, you're still going to humans have a look at the report. You still have humans triage the findings, and you're still going to have humans make a decision of what to do next in that project. So at the end of the day, it's still a human-driven process that is augmented by tools, right? Now, if you think about how does development work nowadays, let's say from quality perspective, a lot of organizations are moving to fully automated quality assurance. And not only that, the decision whether the application passed the quality assurance test is automated. So, and what I would like to challenge you is to think about it the same way from application security. The way to think about application security in a new DevSecOps world is it's automation. Automation makes the decisions. It's automation-driven process. And when there is an exception, where there's something that automation cannot handle, that's when you invoke a human to handle the exceptions. Which means the automation should be able to make decisions on this gating and whether the project can proceed further without any human intervention. So now you start talking about concept of governance as code, where you take your governance decisions and governance criteria that humans used to do manually, and you automate them into your pipelines or intelligent pipelines to make that decisions without human intervention. Okay. So if you think about it, the world of Agile, the world of DevOps is actually built for that. It's built to start implementing things like governance as code. So switching topics a little bit, metrics. If you want to have a successful program, you need to be able to measure it so that the program can show to the executives and the board that they are having an impact. Now, a few slides ago, we went through the example of one of the companies, health companies, that measure their success by amount of money they save to the development team, right? So that was an example of a metric. Now, what happens is that in many cases, we see either metrics that don't exist, or they're completely ridiculous metrics, right? And we'll talk in metrics in a lot more details later in the presentation, but if you have a metric that has some green lights, what does it actually tell you? Well, it's a green, red, yellow. I don't know. What's the context? A lot of metrics are very complicated, or they're flawed to design in the first place. As an example, I'm not sure if anybody heard of a Cobra effect, so where it's an example of a flawed metric. So I think in the earliest 20th century, I'm not sure if this is a true story, but it does prove the point. British were facing a situation in India where there are a lot of cobras. So they decided to incentivize for people to kill cobras. So they start paying out people for everybody who would bring a dead cobra to them, and they would pay them out. So their metric was number of dead cobras. So what did some of the entrepreneurial people do? Well, they got incentivized by killing cobras. But the more cobras there were, the more money they could make. So some people started breeding cobras so they could kill them and make money. So that's an example of a flawed metric where the metric is encouraging the wrong behavior within the organization. Okay. So let's move on to one more. The wrong kind of pen testing. Right. So pen testing is obviously an important part. But in many cases, what we see in organizations is that pen testing is driven by compliance. And there's a lot of misconceptions of what pen testing can actually do for the organization. A lot of people think, one, is that it can find all the issues, which is definitely not the case. Pen testing doesn't find everything. And think of it from a couple of very simple scenarios. One, let's say you have SQL injections. Can pen tester find SQL injections? Yes. If they're not obvious ones and require a lot of manual testing, it requires a lot of time and a lot of effort. And chances are the pen tester may find some of them, but they're not going to have time or skills to find all of them. You have other defect discovery mechanisms that are much more efficient and much better at finding these kind of problems. Or think about, let's say, insecure password storage, right? In most cases, pen testing is not very good at finding these kind of issues. So it's not going to find potentially a lot of issues within your applications. The way we like to think about pen testing, and I really like this analogy, is that pen testing is your badness-o-meter, right? In really mature organizations, pen testing will tell you if your secure SDLC is working properly or not. If organizations design their secure SDLC properly, pretty much all of the issues, with the exception of configuration, maybe a few other simple examples, should be caught early in a secure development lifecycle, way before you actually perform a pen test. So if you perform a pen test and let's say you find a cross-site request forgery in your application, yes, you're going to go fix it, but the big lesson here that a lot of organizations miss is that let's take a look at our software development lifecycle and understand what is broken in our processes to allow this vulnerability to make it into production or pre-production in the first place. It should have been caught way before that. It could have been caught in your design, for example, design reviews. Okay. The other common misconception that a lot of people have about pen testing is that they say, well, we want to do a black box pen testing because we're simulating attackers. Well, that doesn't really work for a whole bunch of reasons. One, you're never simulating attackers with a pen test. When you do a pen test, you have rules of engagement that all pen testers have to follow to make sure that they're playing by these rules. Attackers don't. Pen testers usually have a certain amount of time to do their job, right? A week, 2 weeks, 3 weeks, whatever that amount is. If the bad guys are really targeting your applications, they're not limited by number of weeks. They will take as long as it's necessary to find a way in. And they will do things that organizations don't allow pen testers to do, right? So by doing what some organizations like to do is a black box pen test, thinking that they're simulating attackers, all they're doing is that they're making pen testers' job more complicated, less effective. At the end, it ends up costing the organization more money. Okay. I'll take another break to see if there are any questions.
There was one from one of the people on the chat, backslide 7. You mentioned a couple of software security frameworks, I believe, and they asked if you could share the links to the frameworks.
Right. So there are 2 frameworks. I think I'm assuming we can share it up. It's the SAM that from OWASP that just got released, new version earlier this year. Stands for Software Assurance Maturity Model, which is open source framework. The company I work for, we have a framework as well, which is also open source, and that would be BSIMM, Building Security and Maturity Model. Okay.
Got it. Thanks.
Any other questions? Okay. Okay, so let's move on to the next example of how some of the programs are not really working. Static programs. Now, when static analysis has been around for 15 to 20 years, and a lot of organizations are actually using it nowadays. The challenge with static analysis, it's garbage in, garbage out. If you do not provide your static analysis engine with a good quality data, you're not going to get good results. Now, and what do I mean by that? For static analysis to work well, and it depends on the tool, but as a rule of thumb, you want to be able to have access to full source code, to something that builds or very close to building, so you can perform all of the proper data flow, control flow analysis, right? And a lot of tools require you to be able to build the software. A lot of organizations are integrating these various static analysis tools with development teams that don't have good builds. And in many cases, they don't get good data in for these tools to be able to produce quality results, right? And they produce a lot of noise. They produce a lot of false positives if they're not properly, don't work with good build systems, and they are not really encouraging developers to use their results. Okay. Next example, overemphasis on bugs. And that's going back to things like pen testing and static analysis. A lot of people look for what I call bugs versus flaws. And what do we mean by bug? A bug is a mistake during software development, right? So it's a mistake that the developer did. If you think about cross-site scripting, is a mistake. The developer forgot to do the right thing to encode their output. SQL injection, it's a bug, it's a mistake. A developer forgot to use parameterized queries. But there are some other things that are not bugs. It's not that the developer did something wrong. It's just the way the system was designed is wrong. And that example of a flaw. Again, simple example would be key storage. Somebody said to the developer, you need to store hashes, but they forgot to tell the developer that they need to be salted. The developer did the right thing. The developer implemented what he was told. There was no mistakes in his implementation, but his design was wrong to begin with. So that would be a mistake. That would be an example of a flaw. And what we see with a lot of organizations is that they put emphasis on finding bugs, because doing things like pen testing, doing things like static analysis are conceptually easy to understand, and a lot of organizations think that it's easy to implement those capabilities. But what we're noticing in a lot of organizations that we work with is that flaws are at least half of the problem. And things like pen testing and static analysis are not very efficient at finding flaws in your design. They miss a lot of those flaws, and by that, organizations miss finding their vulnerabilities. And finding flaws is also more difficult. So not a lot of organizations building capabilities to do threat modeling, to do security architecture reviews, and other activities looking at the design and architecture to find flaws in the system. Now, I do notice that in the last couple of years, a lot more organizations are starting to think about building capabilities and building processes for doing this kind of work. But it's still in very early stages if we compare that to things like pen testing. Also, there's been a number of interesting tools coming out that enable organizations to do threat modeling in the last few years. Okay. Next one is remediation process, right? So if you go back to the very first slide that I had, organizations would find bugs, and then what do? They fix them. And a lot of organizations measure their metrics are about number of open bugs, number of closed bugs, number of time to remediation, average time to fix the bug. They fix it and everybody's happy. We fix it. Our metrics are good. Everything is good. But that's really a really simple process, and it doesn't really bring full value to the organization. The way to think about it is that every time you find a bug, there's some value in that bug beyond fixing it that you want to take, use it to make your overall organization better and smarter. Example, we found a bug. We found cross-site scripting, for example. Well, why do we have it in the first place? What else did we miss? Let's go and find all occurrences of this particular issue in the organization, update our processes to make sure it never happens again, so we never find it again in a pen test, for example. So not a lot of organizations do that. They fix these bugs one at a time without context of what happens to the overall organization. And really, that bug is worth more to the organization that the organizations are really getting out of it. And the other way to think about it is the concept that I talked about when I talked about pen testing, that when you find an issue in a pen test, you're really telling you something that's broken in your secure SDLC. So when you find a pen testing issue, get the full value out of it. Go and figure out how to update your program, how to update your processes. Who do you need to train? On what do you need to train? How do you need to tune your tools to avoid that issue in the future? Okay. Okay, I think I have two more. This one is threat intelligence vacuums that I quickly talked about previously, that I'm a big fan of. Pointing out is, many times I go talk to the organizations and ask them, okay, so tell me how you do threat intelligence. And they say, oh, it's awesome. We have this threat intel team. They get all these commercial sources. They're partners with law enforcement. They get all of this data. It's amazing. And they're doing a good job, and they're finding a lot of interesting things, and it feeds into operations. It feeds into SOC. But then we ask them, okay, great, but how do you pass that information to the software developers? And the question we get back is that, why do they need to know? Well, they do need to know, because that makes your developer smarter about application security. It makes your development team smarter. And the smarter the development teams are in understanding not only what our various security defects are, but how people in the wild actually exploit them. The more they know about this, the better they become at writing their software, especially if you present that information in a consumable and actionable way that developers can learn from and use. Okay. And the last one that I think I have on my list is organizations, they embrace the technology stack rainbow. There's new technologies popping up every 5 seconds and the new languages, but only that, people move back to old technologies, right? And if you think about this example, the very first one, shadow IT, there's so many shadow IT organizations out there that write software without central teams know about it. And they may not have the best developers or the guys who know about how software security works. And they would write something with Perl and CGI from God knows how long. So anytime you bring a new technology stack, whether it's new or old, into their organization, you are increasing your attack surface. You're increasing your security debt. And the more that you have, the harder it is to manage it from the programmatic perspective, right? Unfortunately, different technology stacks work differently. You may have one static analysis tool that works on a set of languages, but it doesn't really work on the other set of languages. So how do you address that? And the more heterogeneous your organization is, the more technologies you bring in, the harder it is to manage. Okay. So I'll take a pause again to see if there are any questions on the chat.
Yeah, Eli, so there were 2 questions about the pen testing problem. So if you could go back to that slide.
Yeah, absolutely. Okay.
So yeah, the first question is about the last bullet, and the question from PRSI is, what is the solution you think would be the best for the last bullet, specifically for issues with black box testing?
Right. So, and this is not to say that you should never do black box testing. However, if you think about this, when you do pen testing, you either have expensive guys internally within the organization that you pay a lot of money to, or you work with consultants and you pay them a lot of money to do pen testing. So if you as an organization want to be efficient in how you spend your money and how many vulnerabilities and issues you find with the pen testing, you want to make pen testers' job as easy and as efficient as possible, right? So for example, if we talk quickly about threat modeling. Threat modeling, one of the goals of threat modeling is outline potential ways of how bad guys may attack the system. So one of the ways to think about threat model is a blueprint for a pen tester. So if you have a threat model of your app, give it to your pen tester so they understand not only what they see from the outside, but they also understand how the system works internally, where all the various databases are, what are various threats, so they can think about what should they want to attack to be as efficient as possible. Another example, you can give access to source codes, right? Remember I talked about SQL injection. Yes, if you get a really, really smart pen tester and they're going to spend a lot of time, they will find your SQL injections. However, if you give them access to the source codes, they can run static analysis, they can find all the instances of SQL injection, quickly verify whether they're true positive or whether they're exploitable in your running app, and spend their time looking at more complicated things, right? So giving access to the source code can also make pen testers' job easier and allow them to concentrate on more high-value attacks that tools are not good at, such as business logic testing. And speaking of business logic testing, you can equip your pen testers with understanding what are the true business risks that our business owners are concerned about on that app, so they can target their business logic testing better as well. So the short version, give your pen testers as much data as possible so they could be as efficient as possible with their pen testing.
Awesome.
Okay, and what was the second? And then
yeah, the second question is kind of related to what we just talked about. You mentioned that there are limitations for pen testers, but attackers don't. The question is whether there should be any limitations for pen testers.
Yeah. Okay. So certain things that attackers do, I'm not sure if organizations would allow pen testers to do in the first place, right? Attackers would try to exploit things in production. Most of the time when we do pen testing, it's a big no-no to exploit things in production without permission. They can do social engineering. They can do reconnaissance on a dark web. And any reputable pen testing company that says that they do reconnaissance on the dark web, they're probably not being very truthful. because best case scenario, you have to be borderline a criminal to have access to any really cool data on dark web. So bad guys do all of that. Pen testers don't. So really, it's going back to my original point, is that you want to give pen testers ability to be as efficient as possible by giving them as much data as possible about the system or the application that they're testing, right? And keep in mind, money matters. There are budgets. Everybody has budgets. Nobody can hire a pen tester for 12 weeks to pen test their one app, right? They're 1, 2 week, 3 week engagements. So you have to be as efficient as possible with the time and money that you have.
Thanks, Eli. And there is actually a third question, which is kind of a good segue about budget. And the question is, what aspects would be more important for small startups to consider? Because not all of the topics of the software security initiative could be covered if budgets are limited.
Right. So what I would personally do, if you cannot do everything, is think about which activities give you the biggest bang for your buck, right? A lot of people do pen testing because it's very easy to explain to non-security people and get their buy-in. But at the end of the day, pen testing is probably one of the less efficient way of finding issues in your applications, right? So if you are a startup, and I'm going to make an assumption, which may not be valid, that you have some sort of a CI/CD, I would look at bringing automation into your CI/CD pipeline and use the tools that make the most sense for your technology stack. It could be static analysis. It could be interactive application security testing. It depends on your technology stack. It depends on the applications that you're building. And bring in the right tools that work well for development practices that you have within the organization. I would probably start there from defect discovery. At the same time, if you're a small organization and you're doing business with a large organization, chances are they're asking you for a pen test report, not for how you integrated static analysis into your pipeline. So you have to weigh that into account to see what do your clients want to see from you as the proof of due diligence that you've done. Okay.
Okay. Do we have time for another question, Eli?
Sure. I have plenty of time.
This question is about, I guess, coverage of pen tests and how to document results. So question is whether there is a methodology on how or what should be documented to make sure that the pen testers have an, I guess, organized information. How do you determine how much test coverage you're getting from the pen testers?
Right. So this is now getting a little bit more complicated. If you're procuring pen tests from somebody else, if you're working with larger organizations, chances are they have some sort of methodology. So the question becomes, how do you compare the methodologies? How do you understand the coverage of those methodologies? And different organizations will have different methodologies. So you need to figure out what is the common framework that you're going to have to be able to compare those methodologies to see what they cover and what they don't cover. One of the things, and this is not an endorsement of any of the frameworks out there, is just an example. One of the frameworks is ASVS standard from OWASP, and it stands for Application Security Verification Standard. That has a fairly interesting framework that tells you about what things and what security controls you can test for as part of pen test and as part of other defect discovery activities. So you can try to standardize on something like that and compare vendors' methodologies against that standard or some other open standards, right? I would stay away from comparing against proprietary standards. The other thing to keep in mind is if you ask vendors for their methodology, they should be willing to share that with you, right? Methodology itself and what people test for should not be a secret, right? Now, how they test for and how they use the internal IP to be more efficient or faster or better, that's proprietary data. But what they test for and what their coverage is, that should be accessible from reputable vendors. Hopefully I gave the answer people were looking for. But if I misunderstood the question, please clarify in the chat, and I will be happy to try again.
Okay.
So let's go through next slide. Okay, so now if you're starting to design your software security program, you may want to think about the culture within the organization, because the culture in the organization will drive how you build your program. What we see is that there are two main flavors of culture, right? One is where the software security initiative or program is driven by some sort of a central team, usually under a CISO organization. And you see that in a lot of financial institutions and other organizations that have regulatory and compliance requirements, and financial institutions are usually heavily regulated. So this becomes a governance-led culture, and they focus first and foremost on compliance, testing, and risk management, and then more advanced things as they mature. Another example of a culture would be engineering-led, where the goal to build secure software is driven by development teams, usually within the CTO organization, right? And this is usually more common in ISVs, independent security vendors, or technology companies, right? Where they also may think and talk in terms of product security versus software security, application security, right? So once you understand about what kind of culture you have within the organization, you can think about how you're gonna build the program to fit within that culture. Irrespective, what we usually see is that there are three main phases to building a program. One is emerging, where you program, Here we go. Three main phases. One is emerging, where you're just starting out your program and you're just looking at building your basic capabilities, assigning a person in charge, doing some basic training. Then you mature, and then third one is optimizing. Okay. So here's an example of some of the steps that you can take to build the program in a governance-led culture. Now, it will be a little bit different for engineering-based culture, but I'm just going to go through governance-led culture today. The number one step, and I've talked about that previously, is leadership. You need to put somebody in charge end-to-end who will have the right amount of accountability and the budget and the resources to build the program. Okay. Oh, sorry. Next one is inventory your software. If you do not know what you have within your organization, then you cannot secure. So you need to know, and by inventory software, I mean a lot more than just knowing which applications you have. You need to know what you have. And when we talk about software, it's not just applications, it's not just websites. It's any piece of code that you have within the organization. So for example, if you have a piece of code that automatically deploys your applications into a cloud environment, well, that matters as well. If there are software bugs in the deployment code, then you may have security issues. So you need to know what you have. You also need to know where it is, which is not such an easy question with all the microservices that are being spun up dynamically, on demand, and all of the various containers and cloud-based infrastructure that goes up and down as you need it. It's not that easy, but you need to know where your software is. And you also need to understand when it changes. Because if you know when it changes, you know when you need to do some sort of a security due diligence. Okay? So inventorying your software is what I personally see in a lot of large organizations. That's a very, very big challenge. Next one is select in scope. if you're a large organization, or even if you're a small organization, you're not going to go and try to secure everything that you have. Chances are, in the beginning, you're going to be overwhelmed, and there will be too much on your plate. So you need to select what to focus on first, which usually implies that you have some sort of a risk ranking from a security perspective on how to risk rank your software assets, so you can decide which ones you're going to go after first and decide levels of due diligence that you're going to do on various pieces of your software. Because not all pieces of software are made equal. Some are more risky than others, and that should drive, using risk-based approach, how much due diligence and security testing you do. Now, next one is actually get your network and host security and cloud security stuff right. At the end of the day, bad guys are going after the easiest way into the organization. And if you have the most secure software running on unpatched servers, guess what? Bad guys are not going to try to find application layer vulnerabilities. They're going to go after your network, they're going to go after your cloud, and they're going to do the easy things. So if you have no host or cloud security, then you shouldn't even worry about software security. It's like trying to put your underwear on top of your pants. Like, fix your host up first. Next, do some defect discovery. So look for issues, bugs, and flaws, right? So you know what you have. You understand the security debt that you have within your organization. Pick some small set of things that you can manage. And then once you find the issues, not just fix them, but plan for tomorrow. Okay? Once you understand what kind of security debt you have within the organization, you can start thinking about controls that you want to implement, right? How do you prevent reoccurrence of certain issues? Do you need to implement new security controls in looking into design and architecture and things like that? You cannot select the security controls until you know what you have, both from software perspective and from defects perspective. And then the last step to get you started is to repeat. This is your phase one, and then you're gonna repeat. You're gonna probably hire more people. You're gonna improve your inventory. You're gonna start automating things as much as possible. The less humans do repetitive tasks, the better. You're probably gonna expand your scope, and you're gonna expand which defect activities you do. And then you repeat again until you start ready to mature your capabilities. Okay. Now, how do you actually convince people to do the right thing and to follow the program within the organization? That usually implies transforming the culture within the company. And there's two main things that people need to work on. One is enablement, which is to make an organization better suited for doing application security. So that means investing into people, training, running security champions, or whatever term, like, satellite or any other term that you may hear, security guild. Give developers the right tools that are also properly integrated into their development methodology. And do it as early as possible in secure SDLC. And the second thing that you need to do is to reduce the friction that application security brings to the development community. And the number one thing is to embed security expertise right there into a development community. Having a central team of security professionals doing all the work does not scale. The growth of software is exponential. You cannot hire that many people to stay in line with the overall growth in the software development. It's just physically not possible. The way development organizations do that is by automating things. They are able to write more code, not by necessarily just hiring more people, but making developers more efficient and enabling them to do more. You have to do the same thing with security. You cannot scale your central team. You need to make development teams smarter, and you need to embed security expertise into the development teams. Improving collaboration between all the various stakeholders, and make the software security seamless. It has to work within DevOps processes, not within information security processes. I think I'm going to be switching topics on the next slide. So I'm going to take another break and see if there are any more questions.
Yeah, so there were two questions that remained from the chat. So the first one is, where does bug bounty fit into all of this?
So bug bounty is another example of defect discovery, right? The bug bounty is going to look for issues in your production applications most of the time. So just like any defect discovery mechanism, you need to weigh pros and cons, the cost of that particular defect discovery, and the value it will bring to the organization. Some organizations may choose to start that early in their software security program. Maybe they can find that that is the easiest way to go after the issues. Some organizations may do it later, right? It's really organization specific. There are some companies that have great success with bug bounty programs and some companies that have less success. Okay.
Okay. And then another question is about this slide specifically that you have on the screen. And the question is, how do you incentivize the devs, the product managers, to work together towards these goals?
Okay. So I'll partially answer that in metrics, my next few slides. But the way to start is that you need to think about the culture. And when you think about the culture, you need to think about the goals of your particular development teams. And then you need to think about their objectives and how they measure success, right? So in the very first example that I showed, they chose, and that worked for them, to measure success in cost savings, right? Because development teams spend less time fixing issues. So you need to define your goals and objectives and how you measure success so that you can understand how to influence the various stakeholders. And then if you think about influence, you really have two directions. You can go from bottom up by influencing the developers, team leads to do the right thing. But then you have to go from top down, where you need to start with the executives and get their buy-in into the program, get their buy-in into doing the right thing, and most importantly, getting their buy-in to allocate the time from their development teams to do security, right? So if you don't do both of those things in the context of your culture, of your goals and objectives, then you're not going to succeed.
Thank you.
Okay.
I think that was it for now.
That was it? Okay,
Yep.
Got it. So next, we're going to talk about metrics and how you're actually going to measure the success of your program. And I have, I think, half a dozen slides on this topic. So in many cases, as I talked previously, metrics just don't do a good job. And in many cases, they are truly not metrics. They are measurements. They're a whole bunch of numbers that people collect, that they put together in some sort of a report, some sort of dashboard in whatever tool they like to use. They throw a whole bunch of numbers at the leadership to say, hey, here's what we're doing. We're on 5 pen tests this month. We found $100 we fixed 30 things. But at the end of the day, these are just numbers. What do they actually tell you about whether you're achieving your goals and objectives? They don't really tell much unless you really put your program first, your metrics program. So the way I like to think about metrics is to follow this concept that existed for quite a while called goals, questions, metric, right? First, you want to think about the goal. What are you trying to achieve? Okay, maybe you're trying to achieve is to, reduce number of production incidents, right? So whatever your goal is. Then if you say, okay, if this is my goal, how do I know whether I'm achieving it or not? And to figure that out, you need to think about the questions that you need to ask from the organization to see if you're achieving your goals, right? And once you write down the questions that matter to you, then you can say, okay, for me to answer those questions, I need to have access to the following data and I need to have access to the following data trending over time. And that will become your metrics. It will also tell you what data you need to collect and what to do with that data to be able to answer the question. Okay? So if you don't have a goal and you don't have a question and you don't have trending, then you just have numbers, right? And I like numbers, I like spreadsheets, but that's not metrics. Okay? So moving on, I have a few examples of metrics going wrong. So here's one example. This is your open issues on penetration testing, right? And here's a sample example of how CEO would talk to CISA. Hey, there was a huge spike in open issues in January from penetration testing. I don't want this to happen again. So CISA says, yes, ma'am, I understood. There will be no more spikes. And then goes back to application director and says, let's cancel all the pen testing because that causes spikes in my open issues. And that looks bad on me, right? So there's data here. It's trending over time, but there's no context. So what is the context behind this measurement? What happened within the organization to explain what you see on a screen? So here's another example. Same data, but what it says is that, hey, what happened in 2019, in January, we changed the way we do penetration testing. We're now doing authenticated penetration testing. And that allows us to find a lot more vulnerabilities. We also increased the coverage. Now we're testing more applications. And because of all the other good things that we're doing, this is why we're finding more. It's not because those issues didn't exist. They were always there in the production. It's just now we're aware of them, right? So again, it's the same chart. There's different context. And now you're going to have a very different reaction when you present that data, right? So trending numbers on its own don't tell the full story. Okay. Here's another one. Bad definition. Metrics, just like software, can have bugs. And the way you define your metrics and the way you define your data collection and the way you define calculation can have bugs in it to produce wrong results. So, for example, in this, the manager, the OPSEC director comes to CISA and says, good news, we finally closed this important vulnerability that we found a long time ago at the beginning of the year. And it says too late. Look at the chart in September, your median time to recovery or the average time it takes you to fix the bug really spiked up. So you missed your metrics of how long it takes you to fix issues, right? So the director did the right thing. The way metrics is set up, it looks really bad on him, and he gets in trouble, right? So what's a different example? This particular calculation was not representing open issues, right? So you did your calculation, for example, only based on closed, but it didn't make it based on open. That's a bug in the way you did your calculation that presented data incorrectly and led to wrong conclusions, right? So that's a bug in the way you did your calculation, okay? So think about very carefully when you design your metrics, how you collect your data, how you do the number crunching. Okay. I'll take another break. I think I have maybe only 3 or 4 slides to go. Are there any other questions?
Yeah, so there is a question about metrics, and I think if I interpret correctly, it's more about messaging. And the example is, let's say there are a number of high vulnerabilities found over 6 months, and then the reduction is going from 12 to 6. What's the value that can be driven from that to the C levels, and how do you move from a number to something that's informative to the execs?
Right. So again, you need to think about the goal and what you're trying to accomplish, and you need to think of a context, right? So first question I would think about, okay, why did it go down? What happened? Maybe you're testing less, right? Maybe there were no new software being written on these apps and no new bugs were introduced, so a lot less software was written, right? So the way you show value, usually we see two main drivers. One is cost saving, and the other one is a risk reduction, right? So if you in a situation where it's about cost saving, then you want to think about the cost of fixing pen testing bugs and put it in a context of what else did you do in your program to reduce the number of findings in the pen test, right? So maybe you introduce some sort of things inside your SDLC, and now you're finding issues early, and they would never make it to a pen test. So you want to see that's what happened, and then you can put it in a context, say, hey, we did all this stuff, we found them early on, or developers are now smarter and they introduce less, and you would need to put it in the context of number of software that was changed, number of, let's say, lines of code that was written, and present it like that. You also want to make sure that other factors are not influencing. Did you do many pen tests? Was the quality of pen testers consistent? Things like that. The other thing you can look at it is from not necessarily cost savings, but also from risk management. Okay. Let's say all the factors are being the same number of pen tests, the similar amount of new software being deployed into production, things like that. Then you can present it as in terms of risk. Now, you're going to have to define how you measure risk in your organization. Number of issues is not necessarily the best proxy for risk. Simple example, I'm not necessarily endorsing it, is looking at number of issues per line of code. We pen tested 6 apps that have a total of 1 million lines of code, so we found 6 issues per 1 million lines of code. But next time we run a pen test and we found less issues per 1 million line of code. So you can start maybe presenting it like that. But before you even do that, you need to think about what is your goals and objectives and how you measure your risk.
Okay. That makes sense. Thank you.
Any other questions?
I don't see any for now on the chat, so we're good to move on.
Okay. And okay, so I think I have one more misstep with the way people define metrics is things that they miss or hide. So, for example, if you use CVSS to measure a risk ranking of your findings, and you can say, hey, if this is not exploitable, we're going to reduce the risk too low. And then it becomes non-defined, unexploitable, and then it feeds into some sort of a calculation that you have for overall risk rating for your software, and these things don't go into your calculations, right? So again, it's another example of a bug where you selectively not looking at some of the data and do not feed that data into your calculation and misrepresenting what is truly happening. So take your time, define the data sources, define what goes into metrics calculation, and define how you're going to calculate. Okay, so, I have one more misstep, and I quickly talked about it, is breaking the incentive model, right? Which is the Cobra effect I talked about previously. If you do not think about how the metrics will incentivize the community or the organization, then you potentially may set up your metrics in such a way that encourage the wrong behavior versus the right behavior, right? So every time you come up with a metric, think about how it will influence the stakeholders, right? So if the pen tester is incentivized to find less issues because that means the application is more secure, then maybe they're going to go and watch things on YouTube all day long and not spend time pen testing. So think about all of these factors. Okay. Now, what does it take to actually build successful metrics? Okay. So this is a model that I like to think about. This is not necessarily the model. There are many different ways of how you can organize your metrics and the kind of impact they will have on the organization. This is just one example. So here we have really 4 types of metrics. What you see on X and Y axis are your operational metrics, right? And this is where you measure your capability or breadth and depth of coverage, right? So your breadth of coverage could be a very simple, and it's not really a metric, it's more of a measurement about how many applications, for example, I'm pen testing. I'm pen testing 20% of my portfolio. That could be an example of your breadth of coverage. Depth of coverage is how deep you go in your testing. And this is really your entry-level things about telling you how you've operationalized your program or a specific capability within a program, right? Now, the one that you see at the diagonal line is your behavioral metrics. And how do you actually change the behavior of your stakeholders, right? So, for example, you want your development community to, let's say, do certain things, fix issues sooner, et cetera, et cetera. So you want to measure how you're changing their behavior. You can measure, for example, defects per line of code as a proxy for them doing the right things or things like that. And then overall, the number 4, the red box, is your performance metric, where you measure overall impact on software security posture of your organization. And this is how you can measure how you're reducing the overall risk. An example of what I think some of the more advanced metrics could be to measure that is number of bugs you find in production that you did not know about, right? So for example, if you have a bug bounty and they find an issue in production that you didn't find before, that could be a way to measure the performance of your program, right? Because if you have a well-functioning program, you should have very few instances of where people can find something in production that you don't know about, okay? And then one of the most important things in creating a metrics program is creating a feedback loop, right? So you collect all of this data, you present it to all of your stakeholders, but then the most important thing is to actually look at this data, learn from it, understand what it's telling you about your organization, and feed it back into your security DLC to make it better and to make your development community smarter. So if you're not doing it, if you're not taking the metrics and feeding them back into the development lifecycle to make your organization smarter, then what's the point? Okay, and I believe this is my last slide. So let's go see if there are any more questions.
Any more questions, folks?
I have one, actually.
Sure.
You mentioned feedback loops, and what are some ideal feedback loops that you would feel like that people should build into their SSI process?
Are you talking in metrics specifically or in general?
In general.
Okay, so the simplest one to think about is, I think what I already talked about, is when you find a bug, especially in your pen testing, think about what that bug is telling you about your program. Right? That's the simplest one. So if you found cross-site scripting, which should never happen because you're hopefully running your static analysis tool and that should find everything, then the feedback loop would be to go and investigate what actually happened that you have this issue in the pen test, right? That's an example of a very simple feedback loop, right? But then I think your question was the most effective. Did I get that right?
Just generally looking for your thoughts around feedback loops and which ones, yeah, I guess which ones you find most effective and which ones you find are missing the most.
That's a very good question. I'm not sure if I have a good answer for that. It's so organization specific. right? And how organization works. But another feedback loop that you may want to think about is your training program, right? Not only looking at the processes, so let's say you found a bug, you look at the processes or your tooling to see what's wrong with that, but you can also look at the training program and see if anything is missing in the training program and why are people introducing the bug in the first place, right? Why people in today's world still have cross-site scripting, right? So you can look at it from a training program perspective as a feedback loop, right? You can also look, for example, from architecture perspective. Let's say you're looking at the architecture of the app and you're doing your architecture review, design review, or whatever you want to call it, and you find that they didn't get authentication right, that they have broken authentication. Well, if you're working for a large enterprise, chances are they already have a number of security features in place that are reusable, that allow organizations to go and do authentication of their customers properly using a defined set of things. So if you find that during your design review, then you can close the loop and say, okay, guys, why do you have a home-baked solution in the first place? Why you did not follow prescribed methodology? What happened? That's another example of a feedback loop.
Okay, thank you.
Okay. Any other questions? Okay. If there are no other questions, I think if I think I put my email in the beginning of the deck. If you have any other questions or you want to reach out to me, feel free to reach out via email or reach out to me on LinkedIn. Okay.
All right. Well, thank you, everybody, for coming out to this month's chapter meeting. If you could all do us a favor, if you could please fill out the feedback form and leave us any suggestions you have, as well as signing up for the latest or the CTF we have in July. That'd be great. And yeah, big thanks, Eli, for your presentation. Oh, wait, sorry. Is there another question in the chat?
Yeah, so there's another question. It's from Fernando. I skipped over it because he asked me to, but he wanted to see how Eli's seen DevOps affect SSI. Any comments on that, Eli?
Yeah, so I really think it's an opportunity for organizations to rethink the way they do software security and to do it in a way that fits within the DevOps organization and agile culture, right? I quickly talked about things as governance as code. So if you have DevOps, you really have an opportunity to think about the security rules, the gates that you want to have, and the governance that you want to have over your software assets, and find a way to automate it into your, let's say, orchestration engine, and you start implementing governance as code so you can automate your decision-making process, right? So if you're running static analysis, for example, that's well set up and well tuned, your automation can make decisions on when to run it, to what depth, at what time, against which piece of code, how to consume the results of static analysis, for example, and make a decision programmatically on whether everything is fine or whether you need to block the software from moving forward. So I think the major impact of DevOps on software security programs is to push software security programs to start implementing governance as code.
Thank you. Sorry for interrupting, Adam.
No worries. Yeah, it looks like we're good to go. Thank you, Eli, again for your presentation, and everybody stay safe and take care.
Thanks, everyone.